Hi everyone. Today we're going to work on our last bit of automobile ownership, which has to do with accident investigation data. So we're going to be looking at how they determine how fast you're going when you're in an accident or when you put your brakes on, what type of skid marks are left, and how we can use that information or that data to make some decisions or get some information about how fast you were going. So first of all, there is a person who does this for a living, and that's called an accident reconstructionist. And this is a person with knowledge about both about like crime scene forensics and mathematics, and they help explain the circumstances surrounding an accident. Now, the skid mark is the mark the tire leaves on the road when it's in locked mode. That is, when the tire is not turning, but the car is continuing moving forward, such as the picture that I have for you. Notice that the tire, that it's straight, there's marks on the road, and that's telling us that the tire was not moving, but the car keeps going. Now, the shadow skid mark is when the driver first applies the brakes and the skid marks are light. So that would be like right here. You see how light this area is compared to the rest of the skid mark. So there's your shadow skid mark. All right, now, almost every car now is equipped with the anti-braking system. And this system is most cars that do not allow the wheels to lock up. In cars equipped with this feature, the driver will feel like a pulse or vibrating on the brake pedal, and that the pedal moves up and down, and that the skid marks left by the car with ABS look like uniform dashed lines on the pavement. So in other words, it's not a solid line like it is in the picture. It would be like brake, like a solid line, solid, like skip, solid line, skip, solid line, skip, solid line, like dashes on the road instead of a solid line. Now, that is not the only type of skid mark. There's also what is called the yaw mark. And these are circular tire marks that the vehicle was skipping sideways while at the same time continuing in a forward fashion. So something may be like that. Okay? Now, you can see that they were marking the radius or the intervals of which they're looking at this particular skid mark. Now, we have formulas that we're going to be using. And the first one's called the skid speed formula. The formula that S, which is speed, is equal to the square root of 30 dfn. S is the speed of the car when it's entering the skid, so they can tell you how fast you were going the minute you stepped on the brake. D is the skid distance. F is drag factor, and N is braking efficiency. So D for skid, okay, distance, D for distance, F for factor, N is braking efficiency. Now your drag factor has to do with what is on the road. So it's the pull of the road on the tires. It's the number that represents the amount of friction that the road contributes to your driving. So here in this chart, we have several road surfaces, cement, asphalt, gravel, snow, ice, and their drag factor range. So if you're traveling on asphalt, which is most of the roads, then your drag factor will be between 0.5 and 0.9. But if you're driving on, let's say you hit cement, which is mostly like 78, you're going to be between 0.5 and 1.2. Okay? Now, braking efficiency is a number determined by examining the rear and front wheel brakes. It can be 0, which means there's no brakes at all, or to 100, meaning that the brakes are in excellent condition. The braking efficiency number is expressed as a decimal when used in the formula. So if it gives you a percent, you're going to want to change it to a decimal. Most of the time, it's going to be given to you as a decimal in the problem. Now, the skid distance is the function of the number and lengths of skid marks left at the scene. Now, we're going to be using a chord, which is going back to geometry, a line segment contains 2 points, and something called the middle ordinate, which is a perpendicular segment drawn from the arc of the yaw mark to the center of the chord. And it's used to find the radius of the circle. And we're going to talk a little bit more about that as we get to a problem. Now, we're also going to look at what happens if you have something that's on the top of your car or something that is going to fall off your car where it's projectile motion. So it's a type of motion in which an object is thrown, shot, or ejected subject to Earth gravity and traces along the path of a parabola. Now, if we haven't talked about a parabola before, basically it's an arc. Okay, so it's kind of like if you think of like shooting a basketball and the arc at which it travels in the basket. Now, the trajectory is the path that something takes when an object is thrown, shot, ejected upward or horizontally. All right, so let's take a look at some examples here. Now, a car is traveling on an asphalt road with a drag factor of 0.78. So let's highlight that because that's going to be important here. And the speed limit on that portion of road is 35 miles per hour. Okay, now it doesn't mean that the car is traveling that fast. It just means that's the posted speed limit. The driver just had his car in the shop and his mechanic informed him that the brakes were operating at 100% efficiency. The driver must make an emergency stop when he sees an obstruction in the road ahead of him. His car leaves 4 distinct skid marks, each 80 feet in length. Okay, now we're very fortunate in this problem that each length is 80 feet long. Okay, now if they were not all the same, we would want to take the average of the lengths. Okay, so if you left 3, there's going to be 4 skid marks, 1 for each tire. So you're going to want to, if they're all different, you're going to want to add them up and divide by 4 to figure out what your average length is. So that's what we use if it's not all the same. So what is the minimum speed the car was traveling when it entered the skid? And we're going to round our answer to the nearest tenth. Okay, so we're going to get a decimal answer. All right, so we're going to be using the S equals formula. S equals the square root of 30 DFN. All right, so let's identify our 3 things that we're going to put in our formula. All right, so our drag factor, remember I said F with F. All right, so our F is going to be 0.78. Our efficiency is going to be, remember that's N, so that's going to be 100%, so we're going to make that 1. And our D, remember, is our skid marks, our distance, so we're going to say that's 80 feet. So we're going to put these 3 things into our formula. So we're going to get the square root of 30 times 80 times 0.78 times 1. Okay, so when we do the math, let's see, underneath, let's say we didn't take our square root yet, is 1,872. And when we square root that, we get about 43.3. Okay, so that means the car was traveling about 43.3 miles per hour. Was he exceeding the speed limit when he entered the skid? And the answer is yes. Okay, because remember the speed limit, which is posted right here, was 35. He's going 43. Okay, so the driver is going approximately, we're going to use the word approximately because it's this is not an exact answer, 43.3 miles per hour. Will he get a ticket? Yeah, he's probably going to get a ticket. So let's go probably going to get a ticket. Okay. All right, so let's try another one of these. So Melissa here was traveling at 50 miles per hour on a concrete road with a drag factor of 1.2. All right, so let's highlight that. So we have a drag factor of 1.2. Her brakes are working at 90% efficiency. To nearest foot, what would you expect the average length of skid marks to be if she applied the brakes in order to come to a complete stop? All right, so this is our S. So we have new information here. So we're not finding S here. We're going to be finding D. So S is 50. F is 1.2. And our N is 0.9. And we're on the search is what is D? Okay, so let's put that stuff into our formula. So 50 equals the square root of 30D times 1.2 times 0.9. Okay, so let's multiply what's underneath the radical first. And I'm going to get the square root of 32.4. Okay, we still have our D. Here's 50. All right, now remember, when we're dealing with the square root, we're going to try and solve for that. We're going to square both sides. So I'm going to square both sides so that we're going to get rid of the square root sign. They cancel each other out. So we're going to get 2,500 is equal to 32.4d. Okay, so now we're going to have to solve for d. So we're going to divide by 32.4. Okay, so we're going to get about 77.2 equals d. So that means our skid mark is going to be about 77.2 feet long. Or yes, just double checking my units. There we go. All right, so let's try a different problem now. Let's talk about yard marks. Now remember, yard marks are the ones that are curved, okay? They're not straight skid marks. These are the ones that would be like if you were doing donuts in the parking lot. So we have a different speed formula. Because we're doing a circular look, not a straight look, we have a different formula. So we have S equals the square root of 15 FR. So S is still your speed. F is still your drag factor. So those two are the same. But now we have R, which is the radius of the arc of the mark. Okay, so what we're going to be looking at here is that we're going to have to find the radius. This is the guy that we're going to be using in the problem. Okay, so we need to find this. Okay, so this is our chord. Okay, remember a chord is connecting 2 points on a circle. So we would connect 2 points on the arc. And then we're going to draw a perpendicular line from the arc down to the chord. And that's M. All right, and we're going to be using that. That I think we defined as, excuse me, I have to go back up here, the middle ordinate. Okay, so we're going to be using that to find the radius, and then we're going to put that into our speed formula. So it's a two-part problem. So we have a formula for the radius. So that's c squared. C is the length of the chord over 8m. M is the length of the middle ordinate. And then we're going to do the length of the ornament, m, divided by 2. And we're going to just divide and then add those two answers together, and that's going to give us the radius of the circle. So if I was looking at these yard marks, it would be like drawing a point from here to here would be your chord. And then we would find a perpendicular line, segment. There's our little perpendicular. And that's going to be our M. So this would be C, this is going to be M, and that's going to give us the radius of our circle that they were going to use to figure out your speed. Okay. All right, so we have an accident reconstructionist is taking measures for yard marks left at the scene. A 43-foot long chord, she determined that the middle of the ordinate was measured about 4 feet. The drag factor on the road surface was about 0.8. Determine the radius of the curved yard mark to the nearest tenth of the foot, because we need the radius to figure out the speed. All right, so let's find our radius. Okay, so R is equal to C squared divided by 8M plus M over, I always forget this part, 2. Okay, now let's see if we can identify. Our 43 is our chord. The middle ordinate is 4 feet. And those are the two things we need to find the radius. Okay, so we're going to do 43 squared over 8 times 4 plus 4 divided by 2. All right, so when we do the math, let's see here. What did I get? 59.8. Okay, so that's going to be feet. Okay? And that's going to be the length of our radius. So when we find the radius, now we're going to be able to find the speed. So speed is equal to the square root of 15 FR. Okay, so now we're going to be able to find the speed. So we're going to do square root of 15. F is 0.8, our drag factor. And our radius is what we just found, which is 59.8. We're going to multiply those three things together. I don't have that. All right, so 15 times 0.8 times 59.8. We're going to get the square root of 717.6. And then we're going to square root that answer. And we're going to get about 26.8. Okay, so our speed It's 26.8 miles per hour. All right, so let's try another one of those. We want to know what the speed is at a car that brakes are immediately applied after avoided a collision. It left a yard mark cord measuring 62.4 feet and a middle ordinate of 5 feet. The drag factor of the road surface is 1.2. Okay, so this we're going to have to do both parts in one problem. All right, so we're going to find the radius first. Okay, so here is our cord, and here's our ordinate. So we're going to do 62.4 squared over 8 times 5 plus 5 over 2. Okay, so I got 99.844 is the length of our radius. All right, so let's see if what's our speed. Speed was square root of 15 fn. Okay, square root of 15, 99.844, and n is 1.2. Okay, so 15 times the 99.844 times 1.2. Okay, I get the square root of 1797.192, and then we're going to square root that. Okay, so we're going to get 42 let's go with 4 miles per hour. Okay, and again, we're doing this and we want to check. Let's say the speed limit on this particular road was 40 miles per hour. They were going about 2.5 miles above the speed limit. So they can use that to determine whether you were speeding, whether you were, if there's some other factors involved in some kind of skid mark. All right, so now we're going to have this auto accessory maker wants to test a new type of roof strap. So in other words, if you're looking and you're driving down the highway and somebody has like a mattress strapped to the roof. The cargo is secured to the roof of the car, and the car is remotely operated. So they're going to test this. And it's traveled at 50 miles per hour before hitting a concrete block head on. It was hoped that the straps could withstand the force of the impact. The cargo was secure at the height of 5.5 feet above the ground. Unfortunately, as soon as the front of the car hit the concrete block, the strap snapped, and the cargo went flying over the top of the roof, as illustrated in the path. All right, so let's look at this path. So here is our cargo. It took off when it hit the block and landed here. So we have actually two different things happening. You have the projectile, okay, and then you have the horizontal distance as well. Okay, so the horizontal distance. All right, now both of these are going to use a formula that we're going to use for projectile motion. All right, so basically at 5.5 feet, we're going to figure out how long did it take to hit the ground. So in other words, my pink curve there. How long did it take for the object to hit the ground? And then the second is how horizontal distance did the package travel? So we want to know how long it took and how far did it go. So we're going to have a formula for this, and that's y equals negative 16.1 t squared plus 5.5. Now the 5.5 is the 5.5 feet that the object was above the ground. The negative 16 t squared is always part of the formula because that has to do with the force of gravity. And if you remember when you took physics a while ago, that's part of the force of gravity. So t is time, and y is going to be our height off the ground. Well, we want to know when it hit the ground, so that height is going to be 0. Okay. And we're going to solve for t squared, and actually then solve for t. So we're going to subtract 5.5. Okay, so negative 5.5 equals negative 16.1 t squared. All right, so we're going to divide by negative 16.1. Okay, and we're going to get about 0.3416. We're going to get that as t squared. And again, we're going to square root both sides now so that we can figure out t. And we're going to get 0.58. So it took about 0.58 seconds for the object, the packages, to hit the ground. Okay. Now, the horizontal distance at which is traveled, we also have another formula. We have y equals negative 0.003 x squared plus 5.5. And again, the 5.5 is for the height of the object off the ground. So if it was 7 feet, we would put 7 in there for 5.5. The negative 0.003 is always part of the equation. All right, so x is going to be our distance and y is height. Since we're doing on the ground, how long did it travel before, what's our horizontal distance? We're not off the ground, so we're going to put 0 in for that. And you're always going to put 0 in for the problems that we're going to look at. We're going to solve for x, so we're going to subtract 0.55. Okay, so negative 0.55 equals negative 0.003 x squared. Divide by negative 0.003. Okay, and we're going to get some crazy number like 1,833.333, repeating 3 equals x squared. And once again, we're going to square root both sides. So we're going to get 42.8174, blah, 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 is equal to x. Okay, so in other words, we're going to be about 43. So this has traveled about 43 feet. Okay. All right, guys. Let's see if we have any more. Nope. Let me know if you have any questions. Remember, staying in means we're staying safe. Have a great rest of your day.